Hello, everyone. My name is Kalan Shahida. I'm doing a Bachelor's of Science in Software Engineering. And today I'm going to talk about the fundamentals of the fundamentals of AI. This is based on the Allison course, that is a diploma in fundamentals of artificial intelligence. So today's discussion is going to include data mining. It's going to include Gardner's types of intelligence. The 8 types of intelligence is also going to include the philosophies, and all that is going to be based on all the modules that we studied in the course. The first module is talking about history, trends, and future of AI. So before we talk about all that, we have to first ask ourselves, what is AI? AI means we are building a machine that can perform tasks and requires that can perform tasks that require human intelligence. Such machines can be, we can say that they help humans do certain stuff. They think like humans, they do act like humans. And that also brings us to the dimensions of AI. These dimensions are 4. We have think like a human, we have think rationally, we have act rationally, act human. Think rationally, think like a human means this machine is having model cognition. It can imitate, or we can say it can actually have consciousness. It can actually do whatever a human can do, like it's thinking like a human. Then thinking rationally is like formal inference, like it is just going to do what is required for it to do according to the way it is stated for it. Then acting rationally is like doing the right thing. Like if the machine is told to predict this, then it does the exact thing that it is asked to do. That is acting rationally. Then acting like a human, it means that it is going to display human behavior. That is, it is going to do things like coding, what humans have been doing, things like autism screening, things like that. So that is what it means to display human behavior. Then we have the history of AI. When we talk about the history of AI, we remember Leonardo da Vinci, who created the robot Knight. That was in like 1465 or 1450, something like that, in the 1400s. Then we also have Michelangelo and Pitts. They developed a Boolean model of the brain. Boolean model means it is going to have values of truth or false. Then we have Alan Turing, who is like the father of AI. This one introduced the Turing test. This test considers whether or not computers can think. It is helping programmers, developers to see or to identify whether or not the computers can think or not. Then in the 1950s, we have AI as a research field. People had started to research on AI. Then in 1980s, we have rise of machine learning, whereby people started building machines that are learning, e.g. the machine that was built for checkers, that the machine that would win a game of checkers, that was built during that rise of machine learning. Then we have 1990s, we have the Bayesian networks. This one we had started seeing the expert systems coming about, then knowledge representation of frameworks, things like that. Then relating this with the data mining, well, in data mining, early AI focused on rules, but modern AI relies on mining data. Like you have to look for data and then provide it with that data so that it can follow that data to perform certain tasks. Then we have classification. It's a form of data mining. This is the backbone. Like it is it includes labeling input, like let's say the autistic risk or no risk. This includes like when I say a kid is at a risk of autism, then this person has certain behaviors. So if I identify those behaviors, then I can automatically classify them as autism risk behaviors. Then we have association rules. This can discover links between traits. Like we can say traits like speech delay, traits like head shaking. So when we discover links between those traits, then we have seen the association rules. So they discover discover links between traits. And then clustering. Clustering, you're going to show subgroups of children. You're going to identify these children. Like every autistic person has multiple autistic people have different ways of showing their autism. So we are going to have those ways, we state those ways, and then we shall group we shall get those subgroups we have had. Like let's say we shall have a subgroup of children who have who tiptoe, who show tiptoeing as a symptom, as a sign for their autism. Then we shall have children who have speech delay as their sign of autism. So we make those subgroups. So clustering means we are making subgroups of those children using such symbols, signs. Then we have Gardner. The Gardner's types of intelligence. We have multiple types of intelligence. We have bodily intelligence, we have intrapersonal intelligence, we have logical mathematical intelligence, we have naturalistic intelligence. So logical mathematical intelligence involves algorithms. We look at algorithms, we look at mathematical algorithms. Then linguistic, we shall look at languages, we shall look at natural language tools, like how this autistic child is going to talk, because they will talk differently from normal children. Then we have intrapersonal intelligence. That is, it's a self-reflection, like the child himself, how that person treats themselves. Then philosophy, we talk about weak AI and strong AI. Weak AI is basically acting like a human. It's basically just on information. But strong AI is going to be like a human being, we can say. It can do things like a human being can. But weak AI is going to just try to mimic human nature. That is why I say that our autism screening tool is a weak AI, because it does not understand autism. It rather applies logic and statistics. The second module is problem-solving AI. When we talk about problem solving, we look at the first thing is we have to we have the start state, we have the goal, we have actions. So we have a start state of this problem and the goal we have to reach to and the actions we do to reach that goal. So in the same sense of problems and AI, we have AI technique. It's the method that exploits knowledge. You look for knowledge in different ways, so you exploit that knowledge. Then we have steps of problem solving. That is, first thing you define the problem, then later you analyze the problem and then represent knowledge. Then later you can solve the problem. And solving means you will have to look for the best, the most efficient way of solving that problem. Then we have heuristics. Heuristics are educated guesses. So, and heuristics come from a Greek word called heuristein. This word means find or discover. So heuristics are educated guesses. So they help us to find and discover some certain things. Like in our AI screening, in our autism screening AI, we can say heuristics are going to help us find certain behavior or actional. We have behavior methods of these autistic children. So our autism screening AI would focus mainly on the key symptoms like delayed speech. So that is also showing heuristics. Then in data mining, we can show heuristics by heuristics in AI resemble classification. And remember, classification involves like you have a different in classification, we are talking about rules. We are focusing on rules and what? And we are focusing on the high risk, the low risk. So these heuristics resemble that classification in that way, because heuristics are educated guesses. So they immediately know if you're at a high risk or at a low risk. Then Gardner's intelligence types. We have logical mathematical intelligence is the one that is involved in the heuristics, because we have problem structuring. You structure a problem in a way that you can logically solve it or mathematically solve it. Then you also search through pathways, like solution pathways. You don't just take a solution like that. You have to search through so that you can get the best solution. Then philosophy, we'll talk about deciding what information is relevant, which symptoms matter. Like we'll choose which symptoms are we going to base on to screen for autism. Will we say that this kid is will we identify like a speech delay as an autism symptom? Is it what we will use to identify this autism? That is what we mean by philosophy of you frame the problem without being overwhelmed. Then the third module is talking about problem solving by search. You search, like you're solving a problem, but you're searching through it. So in problem solving by search, we have uninformed searches. Uninformed searches include breadth first search. We have depth first search. Then informed searches, we have ESTA search. What is breadth first search? The breadth first search will have the breadth first search will have a single method, like it allows you to have it does not get trapped on dead ends. You will not have to, if you reach a point whereby you're not getting a solution for that problem, you don't get stuck there. You look for another solution. So that is what the breadth first search focuses on. Then the depth first search, it focuses on being quick. You have to find a solution without all competing branches having to be expanded. Like you have to find a solution quickly without looking for other methods or expanding other branches. Then we also have the and or graphs. These break problems into sub-problems. They also search by termination, like when the and or graph, the and or graphs, we have something like all sub-problems will be and, like you might need to solve all sub-problems, that is and. Then or will be like you get just one of those many problems and solve it, but you will also solve the others, but you have to first get one of those problems and solve it. That is what the or is about. Then games are a neat way to test such strategies. By games, I mean like in games, there are rules that are well-defined and success, and rules are well-defined in games, and success and failure is uncertain. Like you don't know if you're going to win or you're going to lose. So they are a neat way to test such strategies. You can use these such strategies to identify whether this person is going to win or this person is going to lose. So in this autism screening AI, we will use such strategies like the and or graph. We can use it because we need efficient reasoning across behavior reports. Then clustering. Clustering reduces such complexity because it is going to group the cases together. Then that in data mining, we have clustering. So it is going to group the cases together. So it will allow us to solve these problems easily. So if we group autism people who have who show signs of poor communication, who have signs of unstable movement, if we group them together, it would be easier for us to identify who is autistic. Then the gardener's intelligence type will be the spatial intelligence. The philosophy will talk about what if the AIs are usually, they are not cautious, but they usually give us the benefit of the doubt. Like they make us say, what if this happened? What if? They are more of the what if. They give us the what if worlds. Then the next module is the fourth module. We have knowledge representation and reasoning. Knowledge is in stages. The first thing before you become knowledgeable, you have to have data. Like you feed data in your head. Then after that data is into information, then after you can be knowledgeable. But we can simplify it into main approaches. That is symbolic AI, and then we can also have connectionist AI. Symbolic AI mainly focuses on rules and logic. It does not. It just thinks exploits rules and logic in building a system. We use rules and logic to build these systems. Then connectionist AI, we have neural nets and genetic algorithms. This is the current trend nowadays because neural networks help us improve the speed of our machines. Then we have the past order logic. It has been the foundation of logic AI. First order logic was the first logic to be formed. Then we have the autism screening AI. The autism screening AI is going to combine symbolic rules, like the rules plus the neural patterns to look for screen for autism. So it's going to look for rules and logic, then it can solve for us our risk of autism or not. Then data mining, we shall talk about association mining. Like rules from association mining can be encoded symbolically. You can be like, if this child has autism, if this child has this symptom, then that means this child is at a high risk of autism. Then neural nets can handle fuzzy, noisy data. That's why I was saying they make it easy and faster for us for the systems. Then the gardener's type of intelligence will be linguistic intelligence because they will be stating rules, and also the intrapersonal intelligence whereby there is self-awareness, like you can know that because I have this, then that means I have a risk of autism. Then philosophy, we shall talk about Chinese room argument. The Chinese room argument talks about basically it talks about if I know Chinese, if I know the characters of Chinese, does that mean that I know Chinese? No. So does following rules mean understanding, or is the AI just following symbols and manipulating them? Then the next is first order logic in the fifth module. First order logic builds on propositional logic. Then it also builds on propositional logic by allowing objects to communicate, by allowing us to talk to objects through relationships. How? That is, we consider these signs for the predicates. We consider the predicate what? Quantifiers. Because first order logic extends proposition with quantifiers and predicates. So these quantifiers, like this all, the for all, it is an all quantifier. Then this is an existential quantifier. So this one means for all. So for all children with speech delay, it implies they have autism. Then this other one means if there exists a condition whereby there is speech delay, then that means that kid is autistic. Then the data mining, we have the classification models. They can be represented in the first order logic form, e.g. quantifiers, universal quantifiers. But real data is rarely that neat. You can't have such neat data. You can't just have data that completely allows you to drive a conclusion that these people are autistic. Then we look at the Turing test and the Chinese room. So if the first order logic can mimic reasoning, but does that mean that the system understands the autism? No. Then the next one, we have inference in first order logic. Inference is the main, the resolution is the main inference rule. Like it is the most important, because it is combining clauses to derive new truths. So resolution is sound, has soundness, is sound. It also produces valid conclusions, and it is complete because it eventually finds the truth. No matter how many times it's going to cycle, it is going to finally find the truth. Then it requires unification for generality. You have to unify the things so that you can have general output. Then for the autism screening tool, we'll be like combining symptoms to give a logical risk conclusion. That is how we can use the inference. We shall combine different symptoms, then we can give out logical risk conclusions. The data mining, as you can see, inference can also reference the classic pipeline, because symptoms, or you can say features, they imply logical inference, and they also give you a risk label. Then the Gardner's intelligent type will be the logical and mathematical, because we'll be deducing conclusions. We have deduction. Then philosophy, we shall have symbol manipulation versus true reasoning, whereby is the AI truly discovering the truth, or it is just pushing symptoms. Then the seventh module is reasoning under uncertainty. In this real world, we have so much uncertainty. Because the data is noisy, the data is incomplete. So these traditional problem solving techniques would not work for us. So we need to introduce the probability theory so that we can be able to work with uncertainty. We can also be able to work with incomplete data. The probability theory is like working with random variables like 0 to 1, 0.5, 0.2, 0.6, like that. Probability theory plus utility theory, whereby utility theory is weighing goals and outcomes. You have different goals, so you weigh them and then you see which outcome will be better, which outcome is more perfect. Then when you combine the probability theory and the utility theory, you come to the decision theory. So if you make probability of whether or not there is a risk or there is no risk, then and you combine it with weighing the goals and the outcomes, then that means you come to a conclusion or a decision. Then we'll have to also talk about the Bayesian networks. These Bayesian networks usually talk about, in the Bayesian networks, we have a directed graph. It is representing variables and dependencies, like a variable like the child's characters, and the dependencies, like low risk of autism and high risk of autism. So if I have a character like inadequate speech, I'll match it with a variable like inadequate speech. I'll match it with a dependency like that is a high risk of autism. So the data mining Bayesian networks resemble probabilistic classifiers. Then Gardner, we have the naturalistic intelligence, ability to classify things in nature. Then the AI classifies uncertain evidence. In the philosophy, we can talk about can probabilities fully capture human uncertainty? No or yes, something like that. Then we talk about the planning. Planning is quite different from scheduling. Planning is explicitly representing state and goals. Like you're stating your goals, you're also stating what you want to do to achieve such goals. Then planning is about deciding sequences of actions to achieve a goal. We have different methods of planning. We have progression, forward search, progression, but progression can be known as forward search. In progression, we have yes, progression and forward search. Then regression. Regression is also known as backward search. And we also have progression. We can also say it is forward search, but rather we can also say that you choose an action. It's where you choose an action where preconditions are met until a goal stage is reached. You continue meeting preconditions until you reach a certain goal. Then regression, you choose an action that matches an unachieved goal. Then you choose an action that matches an unachieved goal. And then later, you add an unmet precondition. Then you also have to set sub-goals for that. So you continue until those sub-goals are achieved, are empty, as in they are achieved. Then earlier, we had planners in the 1950s, 1960s. We had planners like the logic theorist, which was the first planner. Then we have the GPS. Both the GPS and the logic theorist were developed by Newell and Simon. Then we have non-hierarchical planners like strips. These strips present actions of their preconditions. They present actions by their preconditions and their effects. They present these actions with their preconditions and their effects. So what they add and what they remove, like they are showing you what they are adding and what they remove. So those are non-hierarchical planning. Then hierarchical planning, we have upstrips, but they come from strips. So upstrips are more like strips, but they are rather hierarchical. They are in a hierarchy. So they greatly reduce such space. They greatly reduce this, and they also are more efficient at solving large problems. So we cannot bring strips to solve big problems. Then association mining helps plan sequences. If high risk, then they are likely to need a referral. That is what we are talking about by the association mining. Then gardeners intelligence, we talk about bodily kinetics. Sorry. We talk about bodily kinetics. These are sequencing actions. Then we also have interpersonal intelligence, like family communication, how this autistic person is communicating with their family, with the outside people, something like that. Then philosophy, we can be like, which actions and goals should matter? Which actions should we take? Which goals should we reach? The next is planning and decision making. This is module 9. In real world, multiple agents, like we have in the real world, we have multiple agents, we have a lot of uncertainty, we have data that is undefined, we have all that. So it is limiting planning. So we cannot continue with our traditional methods of planning. So thus the complex planning is introduced. So to solve this complex planning, we have methods like hierarchical task networks. That's the HTN. This one is going to breaking the big tasks into smaller ones. Like if I have like a big task, like doing a big task like that autism screening. So I'm going to break autism screening in two different methods. I'll screen autism screening for like all ages. So I will divide my big task of autism screening of all ages in two different ages. I'll be like, I'll screen people of ages 0 to like 1. I divide that task in two smaller ones, so it is easier for me to solve. And where the hierarchical task networks doesn't work, we can involve the Markov decision processes. This one is going to define the states, actions, probabilities, and give you rewards. Like you will define the state of that problem, then after that you take actions, then you derive probabilities of getting a solution, and then later you get a reward for solving that problem. In autism screening AI, we can say like family support can be divided into subtasks. Like I can say one of these family members is going to be doing the paying of the bills. Then the other one is going to do what? The first one is going to do paying bills for the autistic patient. Then the other one is going to escort the autistic patient to the psychiatrist, something like that. You divide the roles into each other. Then when we say data mining, we say like MDPs, like that is the Markov decision processes, resemble classification, because we say they are defining states, actions, probabilities, and rewards. That is the same as classification stroke regression with probabilities and rewards. They also divide. Then the gardener's intelligence type will be interpersonal stroke. We can call it working with families. You can see how these autistic kids are going to work with their families. Then we have intrapersonal intelligence, whereby they are reflecting on decisions, something like that. Then the philosophy, we shall talk about, does AI's best policy equal to real rationality or not? Then lastly, we are going to talk about machine learning. What is machine learning? Machine learning is going to be defined as machines that learn and adapt from data. We are going to have machines that learn and adapt from data. Machine learning is the heart of modern AI. It is about algorithms that improve automatically from data, sort of like that. It has different learning elements, like performance element that decides on actions, like does the task. Then the learning element is ensure better actions are discovered, like exploration, ensures exploration. Then we have the problem generator, ensure better actions are discovered. That is the learning element. The learning element is to improve with experience. Then the problem generator is the one that ensures exploration. Then we have the critique. It informs you about the feedback, about the performance of the system. Then machine learning has types like supervised learning, unsupervised learning, reinforced learning. Unsupervised learning is finding structure in unlabeled data, like clustering. Then algorithms must determine the data patterns on its own. So you give the system data, and then the system is going to cluster, like it's going to pack that data in different groups. Like if I give a system all the data about the autistic children, I'll ask it to pack in different ways, whereby we have autistic children whose symptoms or signs are like poor language, poor communication. So the machine is going to cluster them in different groups. Then supervised learning is learning from labeled data, like classifying spam messages. The AI, you could provide an AI with the autism data, whereby you label the data. You label that if this one has these signs and symptoms, that means this person is autistic. If they don't, then that means if they experience this and that means they are not autistic. So you label the data before you give it to the machine so that it can learn from that labeled data. Then we have reinforcement learning. It is trial and error. So reinforcement learning, we have we have rewards. So you give the machine certain data, you tell it to classify it, you tell it to work on that data. So if it tries and it errors, you do not reward it. But if it tries and passes and gets it correct, then you reward it with anything. Then it has tasks like classification, where classification is you assign a category to each data instance. That is like temperature or cells, or we can talk about, classification is like you assign a category to each data instance. Is like images. Image classification, you classify this data into images. Then we have regression. Regression is involved with predicting a value for each data instance. That is like when we are predicting the temperature, when you are predicting the cells, when we are predicting the age of certain people. That is what we are doing with regression. Then we have advances in machine learning. We have semi-supervised. It's actually the one that most machine learning tools are using, whereby they learn using labeled and unlabeled data. Our autism screening AI uses supervised learning to predict risk of autism. So data mining, we also have classification. So classification is used to predict autism risk. Then clustering, you have to find autism subtypes. Like that, you group the data differently. Then Gardner's intelligence thing we used. We'll have logical mathematical patterns, naturalistic intelligence. that is classifying children, interpersonal, intrapersonal. We have interpersonal, we have understanding social behavior. Then finally, the philosophy behind this is that, does learning from data make AI intelligent or not?